Single-page applications, known as SPAs, can of course also be clients to the authorization server. They do require some extra attention. The use of BFF, backend for frontend, is an official current best practice when using OAuth and OpenID Connect. I'm Ronald Guit for Duende Software, makers of Identity Server. We help you to create secure applications in your organization. We've seen OpenID Connect in action for traditional server-rendered web clients. For these applications, the UI is handled on the server as well as everything related to authentication. There's an OpenID Connect client library for which we used ASP.NET Core's OpenID Connect handler in the example. For session management, we use the cookie handler, and for token management, Duende Access Token Management. For single-page applications, also known as SPAs, like Angular or React applications, where UI is processed in the browser, we could just find equivalent JavaScript libraries for all these and call it a day. It's a straightforward solution, but there's one important problem here. The tokens, which are high-value targets for attackers, are now sent and kept in the browser. And browsers are not the safest place to keep them, to say the least. They are susceptible to many types of attacks. Tokens in the browser are way easier to steal than tokens on a server. And that's why the BFF, backend for frontend pattern, exists. Here the SPA is split into two parts. We now not only have the browser application with Angular, React or whatever you're using to create the UI, but there's also a part of the application running on the server which handles the complexity around OpenID Connect. And that can use any server-side framework like ASP.NET Core. So how does that work exactly? If users want to log into the JavaScript application, it simply calls an endpoint on its own backend. And that's the BFF. In the example I'm about to show you, it's a server-side ASP.NET Core application, which is the actual client of the authorization server. The BFF then handles the login process with the authorization server using authorization code flow to get tokens. The claims from the identity token and optionally the user endpoint, as well as the access and refresh tokens, are then put in the session cookie which is sent to the browser. At first glance, it might look as if this solves nothing. After all, we still seem to send sensitive data to the browser. However, the cookie is encrypted and signed by the BFF using ASP.NET Core's data protection. And only it has the key to decrypt. And in addition to that, it's an HTTP-only cookie that cannot be accessed from JavaScript, so it's useless to the browser and the SPA running inside it. When the JavaScript application needs to read the user claims, it can't do it directly from the cookie, so it has to call an endpoint on the BFF, which requires the cookie for authentication. When this endpoint doesn't return the HTTP status code 401 unauthorized, the JavaScript application also knows there's a valid cookie and thus a valid session. This endpoint also makes sure that only the front end belonging to the back end can call it. If the browser application wants to call an API, it also calls an endpoint that requires the session cookie. When the API is embedded in the BFF, it can just return the data directly. But if the intention is to call a remote API, a reverse proxy on the BFF is used, which is configured to call a certain API when in this example the /remote prefix is used. Before forwarding the request, it will attach the access token that it can decrypt from the cookie. The API returns the data which is then forwarded to the browser. Here's a code example you can download from here. It's a to-do list application, the front end of which is a SPA using plain HTML and JavaScript. When I try to add an item, HTTP status code 401 unauthorized is returned from the API. But after logging in at the authorization server, it works. Session information can also be shown with the expected claims plus some special BFF ones. One of these is the logout URL to use that contains the session ID. A simple request to /logout would make involuntary logouts too easy. And that's why the session ID is required. Let's see how this all sticks together. This solution consists of two projects. There's an API protected by the JWT-bearer handler and authorization policies. I showed how that works in a previous episode of this video series. We're focusing on the front-end host project. The SPA part exists in www.root. It contains an index.html and some JavaScript files. No SPA library used here, but as we'll soon see, it doesn't really matter if you use one or not. The front-end host project not only hosts the SPA, but at the same time there's also a server companion. This application acts as the client for the authorization server. There's the familiar configuration of the cookie and the OpenID Connect handlers, and Duende access token management is used to do the token management. But this program CS has something extra. The Duende BFF NuGet package is used to turn this project into a BFF. Add remote APIs means we need the functionality to forward API requests to remote APIs, and that the BFF should take care of attaching the access token. Further down, BFF middleware is plugged in, which will check for a particular header. More on that in a second. And there's a call to map the BFF management endpoints. This will add the endpoints needed for the BFF functionality. The most important endpoints are /BFF/login, /BFF/logout, and /BFF/user. It is possible to alter the paths if you want to deviate from the defaults. To show how both an API internal to the BFF and an external API work, the to-do API is implemented twice in exactly the same way. The first implementation uses a controller which is inside the front-end host project. ASP.NET Core's router is made aware of the controller in Program CS. The scheme used for the authenticate scheme action is cookies, so require authorization here means we just need a valid session cookie to access this API from the SPA. And the asBFF API endpoint extension method from the BFF package adds anti-forgery protection. More on that in a minute. When this configuration is active, the API project isn't used at all. That also means we don't really need an access token. The API project has the exact same controller. To use this external API, comment in the code that configures it. Here we say whenever a request to /todos arrives at this BFF, forward it to the external API and attach the access token, which we expect to have a subclaim. Note that a call to /todos still needs a valid session cookie, but now the presence of an access token is checked and it is attached to the forwarded request. Now let's take a look at the JavaScript part. Since all authentication complexity is handled on the server side, all the SPA has to do is to call the BFF endpoints. That's why this can easily be done in no matter which framework or library you use to create your SPAs. Here in the index.html, login is triggered with a request to /BFF/login and logout with /BFF/logout. This must be replaced with the value of the claim I just showed, and that is done in the session.js JavaScript file. When the page is loaded, a request is created for /BFF/user. The endpoint requires a valid session cookie, so it can only be used after a user has logged in. Combined with BFF's cookie requirements, having the CSRF header triggers a coarse pre-flight request in the browser for cross-origin calls. This isolates the caller to the same origin as the backend, providing CSRF cross-site request forgery protection. The BFF middleware I just showed makes sure this header is present. Apart from the CSRF header, you should also use same-site cookies that offer excellent CSRF protection as well. When the request is executed and the HTTP status code 200 comes back, we know there was a valid session cookie, and we can read the claims from the response. The logout URL claim is read and replaced, and the name claim is used to show in the UI. If a 401 is returned, we know there was no valid session cookie and thus the user is not logged in. API calls are in todo.js. It simply does requests to the /todos endpoint. Nothing else is needed since the browser will automatically send the cookie along if it has one. Also, the SPA has no idea if this is a remote API or not. It just calls that endpoint on the BFF. Again, notice the CSRF header. And that's a wrap for this video. Thank you for watching.